This is question number 1 from the 3.3 MyLab Math homework on product rule and quotient rule. And in this question, we're given a function, f of x is equal to the monomial x to the 4th multiplied to the binomial x to the 5th minus 3. And we have two ways we can find this derivative. We can work with the function as it's given to us and use the product rule. And that's what they're asking us to do in the first part of the question. Or we can simplify the function. That's what they're asking us to do in the next part. And once we simplify the function using some algebra, then we can bypass the product rule altogether and just find the derivative using the power rule. So we're going to work it both ways. So let's start with our product rule. Okay, so the product rule says we find the derivative of a product by doing first times derivative of the second plus second times derivative of the first. And in this function, our first function is x to the 4th, and they're the bases of plain old x. So you can do chain rule, but you don't really need to, because when I apply my power rule with the chain rule, let's see what happens. I drop my exponent down, I rewrite the base exactly as it's given, I decrease that exponent by 1, and when I go to tack on the derivative of the base, the derivative of a plain old variable is just 1. The derivative of x is just 1. And if you think about that, that's because x is a linear function. If you have y equals x, that's a linear function that has a slope of 1 and a y-intercept of 0, and derivatives are just slopes, right? So if you took the derivative of just a plain old x, the derivative, the slope, is 1. Okay, so that's why we don't need the chain rule here. We're still applying the chain rule. It's just the base is a plain old x. The derivative of a plain old x is 1. And the same thing's going to happen here when we go to do our second function. It's this binomial x to the 5th minus 3. Again, your base is a plain old x. So when you go take the derivative of the second, you're going to have 5x to the 4th. And you don't need to tack on the derivative of x because it's a 1. And then you have a constant that's being subtracted. So technically, you're subtracting a 0. The derivative of a constant is 0, but we don't need to write that. And we go put all of that into our quotient rule. When we do that, we're going to get first, that's x to the 4th, times derivative of the second, that's 5x to the 4th, plus second, that's a binomial, so I'm going to group it in parentheses, times derivative of the first. So that matches this answer choice right here, except they didn't actually find the derivative of the first and second. They just left it there in that notation. I went ahead and I found those derivatives because that's would be the next step. But let's go ahead and clean this up real quick. So multiplying those first terms together, what do we end up getting there? We're going to get that our derivative is x. So let's see, 5x to the 8th. We keep the base the same and add the exponents. And since we're adding, we don't have to be super careful over here, but technically, just to keep things clear, I'm going to change the order of this multiplication in this second group right here, just to clarify a little bit about what's happening algebraically. I'm going to put the 4x cubed first and the binomial second, and then it's a little bit more clear that I need to distribute the adding and the monomial into the binomial. If that was subtraction, it would change all the signs. It's adding, so it's not as... We don't have to be as careful, but I'm just going to rewrite it that way. And then we can see we get 5x to the 8th. And when we distribute, that's plus 4x to the 8th minus 12x cubed. And we'll go ahead and combine those like terms there. So we'll end up getting the derivative is 9x to the 8th minus 12x cubed. Okay, and that's the derivative I can put in to my math lab. But there was another way we could do this. We're being asked to also find the derivative by simplifying the original function. Notice there's no prime notation on that. It's just a regular original f of x function notation. So now we're going to revisit this function by simplifying it first and then bypassing this product rule altogether, and we're going to end up getting this exact same derivative. So let's see what that looks like. Okay, so let's start fresh. Let's write that original function that we were given here. Let's rewrite it. And this time, we're going to simplify this function first with some algebra. So we have a binomial to the understood exponent of 1. Because there's just one old binomial there, we can distribute the monomial to each term in the binomial. Now, we couldn't have done that if, for example, there had been an exponent of like, I don't know, the binomial squared or the binomial cubed. Then we would not be able to distribute. So why is that? That's because according to our order of operations, according to PEMDAS, distribution is a type of multiplication and exponents come before multiplication. So if this binomial had been trapped by an exponent like 3, 2, or 3, or 4, or 5, what we would really be doing there is we would have to expand the binomial. In this case, my exponent that I wrote there was 3, so I'd have to expand that binomial. I'd have to address that exponent first, and then do all the multiplying and distributing after that point. So that's just a lot of algebra there. So if my original function had the binomial with an exponent that wasn't a 1, we would just want to do product rule, right? But that wasn't the case. The function we were given was just a plain old binomial. So because of that, I can distribute the monomial to each term. So let's see what happens when we do that. So then I'm keeping my original function notation because only algebra is happening here. When I distribute, I'm going to end up getting x to the 9th minus 3x to the 4th. And that's what we're being asked to do in the second part of the function. So we were asked to write out the product rule. Then we were asked just to simplify the original function. Simplify the original function. Here I've simplified my original function. Now when I take the derivative, I should get the same answer as before. So now I can bypass the product rule altogether. I'm just going to do power rule now. So I'm taking my derivative with the power rule. The power rule says you drop the exponent down to the front. Okay, so I'm going to do that. I rewrite the base exactly as it's given to me. I decrease the exponent by 1. So that would decrease to 8. And then technically I'm tacking on the derivative of the base, but you know, that's just a 1, so we don't have to write it. Minus, and then again I do my power rule again. So I drop down my exponent. That'll be minus 12. I rewrite my base. I decrease the exponent by 1, and I multiply by the derivative of the base. Just 1, and we end up getting the exact same derivative as our previous method when we applied our product rule. So just to recap, this original function we were given had 2 ways to find the derivative. You either do the product rule if you want to use the function as it's given to you, or you can clean up the function with some algebra. You can simplify the original function with some algebra first, and then do the calculus. You can choose which way you want to do it on a quiz or a test, but this question asks you to do it both ways. So if you have any follow-up questions, just shoot me an email or come see me in office hours.